Hey, I'm so sorry. I completely forgot to make the screencast for you this week. So my apologies. Here is how you need to finish your spreadsheet. So you did the first top half a few weeks ago, and now we're going to be doing this part starting in row 44. So a molar mass of oxalate ion is just going to be the mass of 4 oxygens plus the mass of 2 carbons, and that will end up being 88.020 is what I got. And then the concentration of the standardized KMNO4 depends on what bottle you used. I'm just going to plug in a number here. It may or may not match what you had. And so you've got these two. Now this is red. I know that this is red. And so technically what you're supposed to do is take this value right here from up here. Don't do that, because what I did is I took all the values that all of you submitted to get the average of each bottle, and I think that's going to give you more accurate answers than if you just go and use your average from your 3 trials. Okay, so use the average that was on the board. I will put those in the Moodle message that I send out so that you have the value for your bottle. Okay, massive green crystals, you measured these out. Again, I'm just going to make up some numbers here based on what people had. And then your initial and final burette readings, you're also going to have to fill those in from your data in your lab notebook. So I'm going to just put some numbers in and come back in a second. Okay, so I just put in some values for initial and final burette reading. Now I'm going to get the net volume. It's just going to equal your final minus your initial. And then you just need to click and drag to find moles of permanganate. Just think of the equation molarity equals moles per liter. Here's your molarity. These are going to be your liters. You're going to have to convert them to liters because right now it's in milliliters. But to find moles, it's just going to be molarity times liters. Okay? So I'm going to click this box. You need to add dollar signs so that it keeps on drawing from that same cell. And then I'm going to multiply by my volume, my net volume, divided by 1,000, because I need to change it to liters. Click, drag. Okay, to find moles of oxalate, you need to go to the balanced equation. So this is your balanced equation right here. We are trying to find moles of oxalate, so that 5 goes on top. We are trying to change or convert from moles of permanganate, so that will go on the bottom. So basically you're just going to be multiplying this number right here, and I'm sorry these are so small. I should make this bigger. You're going to multiply this number right here by 5/2 to cancel out permanganate and give you oxalate. Click, drag. Mass of oxalate. You have moles, you got to find mass. Simple conversion. Moles to mass, multiply by molar mass. So equals moles times molar mass, enter. Click and, oops, drag. Okay, sig figs. This has 4 sig figs. This one should have 4 as well. And so all the rest of these have 4 sig figs. So make sure that you have the right number as long as you're within 1 I don't take points off. Of course, you wouldn't know that because I haven't gotten any papers back to you yet. I'm not sure why this one is not doing anything. Okay, so when this happens, what it means is that the number is smaller than Excel wants to recognize. So I'm going to right-click, go to Format Cell, go up to Number, see if that works. Why did that not do anything? Oh, see? You see, if I had been with you in class, you would have told me, but Professor Dimmer, you need to put a $sign in front of cell C44 so that it will actually pull from the same place every time. So $sign, $sign. Now click and drag. Sorry about that. Okay, so then let me scoot this over. Percent oxalate by mass. Is just going to be, this is my mass of oxalate, divided by the mass of my crystals that I titrated, times 100. Yes, that's high. Yes, that's okay. Average is the same average that we've been doing all semester that you will continue doing next semester. And then standard deviation, and select the ones that you need to find the standard deviation of, close parentheses, enter. Relative standard deviation, remember, this will sometimes be called uncertainty. This will sometimes be called relative uncertainty. We just use them interchangeably, and yet we don't usually explain that to you. So I'm explaining it to you. This is in parts per thousand. So if it was a percentage, we'd multiply by 100, but it's parts per thousand, so multiply by 1,000. So I just made these numbers up. This is a little bit high. Usually less than 15 for RSD is great. But that should be all you need to do for your spreadsheet. Then if we look at Moodle, what you need to turn in is a cover page, complete spreadsheet with the standardization data that we did for Thanksgiving, the balanced chemical equation, which I showed you. I'll show you again. There it is. Sample calculations for these cells, D10, G10, H10, I10, ENI 34, FG, HIJ 48, and J 53. And then you need to do NCR pages. So you're going to be showing some calculations from up here in row 10. You're going to do some from row 34, and then you're going to do some down here too. So that should be it for your report due on Thursday. See you tomorrow.